Okay, yeah, here we go. So in the previous couple videos, I went over how to solve speed problems. This one. And this was the examples from the slideshow for how to solve velocity problems and problems related to velocity, so like displacement problems. We're going to continue with problems 5 through 10. So that's these from our speed and velocity worksheet. And we'll start with number 5. It says, what's the velocity of the bus in number 4? You got to look at a map and use some cardinal directions. So let me pull that up. I'm going to go fancy. Since I'm a pilot, I'm going to use this website called SkyVector. And I'm going to fly from LAX to SFO. And so when I put in a little flight plan on here, it'll give me the directions. But you could be simpler. Right? I'm going to get the actual degrees here, but you could do something simpler, like just describe which way it is on a map. So I'll show you how to do both those. Okay. This map is kind of sad right now. See all those red boxes? Those are all the fires. Right? They're not just in California. They're all over the West. It's insane. All of those are called TFRs, or temporary flight restrictions. You can't fly in there without permission because there's firefighting aircraft that are in those areas dropping water on fires. Anyway, we are down here. There's LAX, and San Francisco is up the state right there. So if you look, all right, from here to there, San Francisco is not actually due north. Right? It's opposite the direction I'm pointing. Right? Kind of hard for you to turn my finger that way. Let me try this one. So it's this way. So what way is that? If up is north and left is west, this would be northwest. All right. And if I wanted to, I could pull up a little flight plan thing to actually get the directions. And here it tells me, all right, so I did that. You can see the path. It'd be 308 degrees. So if you think of north as being 360 and left or west being 270, this is 38 degrees north of west. All right, so it's almost in the middle of north and west. So, fancy stuff. Okay, let's try the problems. So for this one, all right, for the velocity, well, I said a bus. Well, so, but yeah, remember, velocity doesn't care about your in between path that you take. It just cares about start and finish. So for problem number 4, all right, so this is problem 4. We're talking about a displacement of 385 miles. And we're saying this is going to be at northwest, or if you wanted to use my stuff, it was 308 degrees. And so that's my displacement. I could also call that delta x. And my time, we said 8 hours. And so to figure out that velocity, what would we say here? All right, so velocity is going to be displacement over time. All right, so these are my givens. Sorry, this is my equation. I forgot the unknown. My unknown is velocity equals question mark. And I'm giving it this little arrow on top to show that it's a vector. Same thing with displacement. Okay, so substitute in. All right, so we'll say 385 miles northwest divided by 8 hours. And so this ends up being the same as what we got when we did it for speed, just now we have a direction. So 385 divided by 8 equals 48.125, and that's miles per hour northwest. We only get one significant digit. So this is my cut line. I'm going to use the 8 to tell me what to do. And the 8 is telling me to round up. So I'll write 50 miles per hour northwest. All right. So same thing, just adding in the direction. Now, if I took a flight, the speed would be quite different. So let's figure that out. All right, so that flight is going to be direct. It's going to be in a straight line. And we were really just imagining that this bus trip was a straight line too. So this is problem 5. And problem 5 says, what's the velocity? Oh, whoops, my bad. I just did problem 5. Now it's time for problem 6. Sorry. Okay, here we go. So it says if you take a round trip flight from LA to Sacramento, one way it takes you 1.25 hours. What would your average speed be? Now remember, you're taking a round trip flight. So your average speed. Okay, so my given is, let's see, that the distance, 385 miles. The time, 1.25 hours. My unknown is going to be speed. My equation, speed equals distance over time. I'll substitute in distance, 385 miles, time, 1.25 hours, and I can solve, and 385 divided by 1.25 gets me 308 miles per hour. So this is my average speed. If you notice here, I've got 3 significant digits in the distance, 3 significant digits in the time, which means I get to keep all 3 significant digits in my answer. And so this is my answer. There's no direction because it's a speed, and that's it. For number 7, students interpret this question differently. It says, what's your velocity in number 6? So if you're talking about the round trip flight, all right, so for problem 7, if you're talking about the round trip flight, what's the round trip velocity for anything? That was supposed to be a question mark. It's 0. Right? But if you think of it as just the single trip, or the single one way, there we go. So one way velocity. You don't have to do anything different. It's a straight line. The plane flies in a straight line. So you can consider the velocity to be the speed with a direction added to it. And so that'd be 308 miles per hour. And you could say northwest, or you could say 308 miles per hour at 308 degrees? I think it was. Yeah, that's a coincidence. 308 degrees. All right, so either of those would work for problem 7. Moving on to problem 8. Here's problem 8. A slug crawls onto a meter stick. The slug crawls from the 20 centimeter mark to the 50 centimeter mark in 1 minute. What's the velocity of the slug in meters per second? Ooh, I'm going from minutes to seconds and centimeters to meters. And notice we're not starting at the 0, we're starting at the 20. Oh my goodness. So many things to deal with here. Okay, well, let's do it right here. Given. There's a lot of information to sift through here, so writing down your givens really just gives you time and space to just pull the information out. Okay, so I'm going to write X initial. That's my initial position is 20.0 centimeters. X final is 50.0 centimeters. Time, 1 minute. You know what? Right now, you could see that we want the answer when something to do with seconds. This is such a simple thing to do. Just call it 60 seconds. You don't have to do a conversion factor problem. This is it. Okay, so I'm going to make that conversion right now. Okay, that's all I have. Now my unknown, I want to know velocity. Velocity equals question mark. Equation, there's two. First of all, I need to figure out the displacement. So that is the final position minus the initial position. So that's one of the equations. The other equation is for velocity. Velocity is equal to the displacement divided by the time. All right, do you see all that? There we go. Okay, so I need to solve both these things. I think I'll have enough room to just do them side by side like this. So displacement, final minus initial. Okay, so delta x equals, our final position was 50.0, our initial position was 20.0, and so that ends up being, let me solve that part, that ends up being 30.0 centimeters. Okay. Over here, all right, I can take this and plug it in up there. All right. Okay. So my velocity is now going to be 30.0 centimeters. Ooh, which way? You know, it doesn't say. So I'm just going to put a positive here. All right, and the positive direction. All right, that's the best I can say about the direction. And then for the time, it was a minute, and we were supposed to get it in meters per second. Is that right? Yeah. All right, well, I can write the time in seconds, and that gets me a velocity in centimeters per second. Okay, well, that's cool. I want to change it to meters per second. So how do I do that? Well, let's do that over here. So currently I've got 30.0 centimeters, and I want to change it to meters. That means I need centimeters to go away and be replaced by meters. For every 1 meter, there's 100 centimeters. Remember, century, 100 years, centimeter, 100 centimeters in a meter. All right, centimeters cancel, and I end up with 0.300 meters. The reason I put these 2 zeros here is because I had those 2 zeros of significance from before, and I get to keep them. So I'm going to leave those there as a reminder. Okay, so I'm going to take this and stick it up here. So now my velocity is equal to 0.300 meters divided by 60 seconds. And that's the positive direction. And let's see, when we divide these things, 0.3 divided by 60, and I end up with 0.005. And I get to write this with 3. Ooh, how many digits do I get to write this with? Do I get to write it with 3? Dilemma. You know, it says 1 minute. This is a little bit tricky. So it depends on how I write it. And I think most folks haven't done this yet, so I'm going to change this so that it looks like that. 1 minute with 3 significant digits. So that means that I get to write this with 3 significant digits. So what does that look like? Well, that looks like these ones aren't significant, the placeholders, but if I put 2 zeros after the 5, then all 3 of these are significant. And they tell me how high of a degree of accuracy I have with my answer. And this would be meters per second. All right, so my final answer is positive, that's my direction, 0.00500 meters per second. And I know that's probably a little tough to see down there at the very bottom, but that's it. Okay, scooting along. Problem number 9. It takes you 23 hours to go from Omaha to LA at a velocity of 70 miles per hour west. How fast are you from your starting point? Basically, how far apart are these two things? So, problem 9. Given time, 23 hours, 2 sig figs there. Velocity, 70.0 miles per hour west. 3 significant figures there. Unknown. Let's see, it is a displacement. Delta x equals question mark. Equation is going to be velocity equals displacement over time, which I can rearrange to be displacement equals velocity multiplied by time. And now I can substitute into that equation displacement equals 70.0 miles per hour west. And we'll multiply that by 23 hours. And this is nice. The units are just going to cancel for us, pew, pew, leaving us with miles. All right, so I'll solve displacement equals, ooh, I don't know what this is. Maybe I do. 140 plus 210, so 1,610, I think is what it is. Let's see, 70 times 23. Yeah, cool, brain still works. 1,610 miles west. I think, yeah, that's it. How far am I from the starting point when I end? Yeah, I'm 1,610 miles west of where I started. Do I get all these significant figures? I don't. I only get 2. So I'm gonna cut it here. The 1 tells me to stay, so it's 1,600 miles west. All right, that's my displacement. All right, for the last one, we'll flip it over on the back. It says, Destiny walks 1 meter north, 8 meters west, 1 meter south. It takes her 4 seconds to do this. Draw a diagram and find her average velocity. Okay, north is up, so we'll go up 1 meter. West is, oh, I didn't plan this out very well. Let me start over. All right, because west is usually to the left. So we'll go up, or north 1 meter, and we'll go west. We'll call this 8 meters west, 1 meter north. Never hurts to label stuff. South 1 meter is going to be just as far as I went north, so that's kind of nice. All right, so this is 1 meter south.